Okay, today we're going to talk about notes 4, which is solving multi-step inequalities and variables on both sides. The first thing we want to talk about is, remember when we had something like 10 less than x, okay? So when we would write this, because we have a tricky turnaround word here, we would flip it around and have x minus 10. Do you remember that? Okay. Well, what we're going to talk about now is if I had something like 10 is less than x. This is going to give me a completely different problem. Okay? What changed from this sentence to this sentence? Other than me writing the 10 out. Zachary?
The equal sign changed into like a test.
But I don't have an equal sign here.
It's.
What changed from this sentence to this sentence? Emmanuel?
So instead of the minus sign, we do the less than or less than.
Okay, but what changed from this sentence to this sentence? Jake?
One word.
What word? Is. Is going to tell you that we are not writing an expression. We're going to have what Zachary was telling us is a less than sign. So because of that one little bitty word, 2-letter word, we have the word, the inequality of 10 is less than x. That is the only thing that changed. Okay. Now, I just hit on that. You have a few problems over today. It's going to be incorporated in other stuff as well. Okay. The next thing is an inequality. When I'm graphing an inequality on a number line. Okay. You're going to have to do this for like 3 problems today. That's all I expect you to do for like 1, 2, and 3. Just as practice. So if I have my number line, when I'm talking about what you're going to do in your number line, it can be something super simple as like if 0 was my number, or we're actually going to go with 2 is my number, I'm just going to draw a circle. I don't have to have any of these other numbers. I've got my 2, and then I've got my arrow on which way it's pointing. Now, do we remember what that open circle means?
Yes, it's not equal to.
It's not equal to, so it's just less than or greater than. And so that's when we have an open circle. CIRC. If I could spell, that would be great. Okay. We could also have a closed circle, which I've already said is going to have that equal sign of less than or equal to or greater than or equal to with a closed circle. Are there any questions about any of that right now?
No.
Okay. Okay, our next problem. I'm going to move this up so that we can see. Is negative 6n plus 5 plus 4n is greater than or equal to 17. So how would I need to solve this problem? Combine my like terms. So I've got my like terms as negative 6n plus 4. And then I've got positive 5 and 17. So negative 6n plus 4 is negative 2n bring down my plus sign, is greater than or equal to 17. And now what do I need to do? I subtract my 5. So I get negative 2n is greater than or equal to 12. Then what do I do? Divide by negative 2. So I get n is greater than or equal to negative 6 or less than or equal to?
Less than or equal.
Okay, but that's a greater than or equal to sign.
Yeah, but you flip it because it's negative.
You flip it because you divided by a negative. So, here's the deal. When you multiply or divide by a negative, okay, you flip the inequality. Every single time. Okay? This is not like I'm doing it once, I'm done, right? No. Every single time you flip your inequality. And I'm going to show you how that works. So, if I had 6 is less than 8. That's a true statement, right? 6 is always going to be less than 8. Okay? If I'm going to divide this, both sides, by negative 2, I'm going to get negative 3 is less than negative 2. Is that a true statement? Is negative 3, I'm sorry. This should be negative 3 is less than negative 4. I'm not paying attention to what I'm doing. Negative 3 is less than negative 4. Is that a true statement? No. So this is false. Okay? But what would make it true? If I flipped my inequality sign to have negative 3 is greater than negative 4, it's true. Okay? So that one little thing makes a problem from being false being true. Okay? And so that's how it works. Another example, if I have 10 is greater than 5, that's true, right? But if I multiply by just say negative 1, I get negative 10 is greater than negative 5. And that's false. If I flip my inequality sign, it would make my statement true. Okay? Are there any questions over that? Comments, concerns? Okay, I have to flip the page. If you are still on the same page, that's perfectly fine. But I'm flipping my page and I'm just going to put notes 4 continued so that I know that this is still notes 4. And so I've got negative 6 x minus 20 is less than or equal to 2 times 2x plus 5. So, what's my first step? I'm going to distribute multiply. So I get negative 6x plus 120 is less than or equal to, but I got to distribute on both sides, 4x plus 10. So what do I need to do now? Combine like terms. All of my like terms are combined on my left and on my right. So now what do?
Take away variable from one side.
Okay, so where do you want to? What variable do you want to move?
Add.
Let's add 6x. Just because I want to show you something. So I've got 120 is less than or equal to 10x plus 10. And so now what do? I subtract 10. Perfect. So I get 110 is less than or equal to 10x. I do it. Divide by 10. And I get x is greater than or equal to 11. Now, there's another way I could write this, right? I could also write it, okay, flipped around. So I could write it x and I have 11. Pay attention to your inequality, okay? It opens to my x. Don't have that change. Don't keep this inequality if you flip it around. Flip it to where your inequality still opens up to your x. I know you guys know this. The alligator or crocodile eats the bigger number. That's how you were taught for the longest time. Okay, your inequality sign has to open up to the same number. But these two are the exact same. Now, I'm pulling out, this is what we did first period. So we moved our 4x to the left side, which is perfectly fine, but we ended up with a negative number. And so we had to make sure to flip our inequality, okay? So just make sure that if you had moved your 4 to the other side, that when you divide it by negative 10, you flip your inequality. Okay, last thing, we've got specials with inequalities. So, these are a little bit, we went over this when we talked about regular equations, okay? So, I just wanted to touch on this to make sure that we remembered. If we solve an inequality and our x's cancel out, but our statement is true. So if we get something of 0 is less than or equal to 0, or 15 is greater than 2, or negative 8 is less than 10, okay? All of these are true statements. Okay? If you get a true statement, you have all real numbers. Only if it's a true statement. If it ends up being a false statement, like 4 is greater than 4, why is this a false statement? Because it's not equal to, there's no equal to sign. If I've got 5 is less than 2, or let's say 10 is greater than or equal to 16, I would get no solution. So you can still get no solution, you can still get all real numbers with these problems. Okay? Are there any questions over any of these problems?